Greetings everyone, I am Chirag from my E-Yantra team and I am here to explain what we did in E-Yantra. Let's begin with our task. Our task in this project was to make a drone which should scan a planet's surface and look for organisms on the planet and send the data of the organism to a satellite. Here organisms are IR LEDs and the satellite is a ground computer. To get additional information on the theme, you can visit the link below. This is the surface of the unknown planet we will be considering in this problem statement. And this is the location from where our drone would be taking off. This is the drone which we are using for this project. It is a Swift drone made by eYantra and it has Raspberry Pi as its brain, and the flight control on this drone is Crazy F4 level. Here you can see the LED clusters as our organisms. Now let's look on to the live demonstration of what we were able to achieve in the stage 1 of the competition. Here we are using Roswell and Gazebo to simulate the entire drone environment. So as you can see, drone follows a search algorithm in the map and it detects the organisms. It tries to center it around its center point, and once it centers, it notes down its location and publishes it to a proper watch topic. Here we are evaluating our run by using a ROSBAG file which was provided to us by eYantra. And now as you can see, the drone is searching in other points to check whether there are different organisms. This is the second organism. The drone detects this organism and it will also publish the data regarding this organism onto the same ROS topic. So our drone is capable of identifying any n number of organisms throughout the run. Now let's discuss about the search algorithm. The search algorithm which we have used is pretty similar in the stage 1 and the stage 2 of the competition. The search algorithm has been written in such a way that if you input the map dimension, the overlap which we require between the frames, the frame size of the drone camera, the altitude of the drone, then the algorithm can itself determine the search path the drone has to follow to cover all the points such that no organism has been left out. We had to also undertake extensive PID tuning for stable drone performance and also for quick response of the drone, as this entire stage is also timed. The quicker we complete the entire task, the more points we get in the stage. The implementation of this task were easier than the hardware implementation because we don't have to face the hardware constraints which we face in the next stage. That I will be discussing while we see the hardware demonstration. As all the search points have been completely searched, our drone goes for landing at the point where it took off. After landing, the drone automatically disarms itself. Now let's look at the stage 2 of the competition. This is a hardware stage. In this stage, we were given a camera which we had to calibrate to remove the fisheye effect. You can see here that my friend is placing an organism in the arena. Here is an arena. In this problem statement, we had to keep our drone in any one of the corners, and drone had to automatically decide its search algorithm based on its takeoff location. But the landing location remained fixed. Now let's look at the demonstration. Before takeoff, drone makes certain beeps and also changes LED lights. There are 4 windows here. One of them is showing the actual drone. The second shows us the Vicon coordinates of the drone from the overhead camera. Third is the terminal window in which our code is running. Fourth is a plot juggler screen. You can see various plots on the plot juggler screen. These plots show us the error in the drone coordinates. In our case, we are not controlling the yaw of the drone. It is controlled by the flight controller using its IMUs. You can also see some constant lines here. These lines represent constant errors of 0, plus minus 6 cm, plus minus 8 cm for understanding how our drone performs. So as you can see, our drone is performing pretty good in its search algorithm. With even more rigorous PID tuning, our drone can achieve even better performances. As previously mentioned, our drone can take off from any four corners of the map and can automatically determine its path and also make sure to land on the edge where eYantra logo is present. As you can see, our drone is landing now. As soon as it lands, it makes some beeps and also disarms itself. Due to the way our algorithm is written, even though it goes outside the Vicon frame, our drone returns back and continues its landing procedure, thereby avoiding any mishaps. Now let's look at the demonstration for finding the organism, identifying it and publishing its location. The organism is placed by my friend at a random position which we determine using a random location generator. This location consists of rows and columns, rows determined by the alphabets and columns determined by the numbers on the arena. Here you can see a blue window. This shows us the live feed from the IR camera on the drone. As soon as the organism is detected, the drone will try to center it, and as soon as it centers it, it will note down its location and the number of LEDs and also determine which organism it is and publish it onto a ROS topic which you would be able to see on the terminal. As I had mentioned earlier, we had faced many practical challenges while implementing this. One of them was the spikes in the change error which we used to calculate D in the PID. This was caused due to noises in the IMU's data which we tackled using a Butterworth filter. The second issue which we faced was due to the constant discharge of the battery, the throttle base value would change throughout the run. To tackle this, we implemented an algorithm which automatically, using the flight characteristics of the drone, would set throttle such that it always compensates for the reduction in the battery voltages. The control loop frequency was made sure to run at a constant speed of 60 Hz. It was also ensured that in case if the organism goes out of the frame of the drone camera, the drone would try to bring it again into its frame, and if it couldn't, then the drone returns back to its position where it first detected the organism and would continue with its search algorithm. This would ensure that drone doesn't crash.